We have this predator-prey model with the cosine function given representing the population of the predator in this model, and T is in years. So what it's saying is, in this model, there's a certain species whose population follows a periodic function. So it follows the same pattern. It'll be at its maximum value, and then it'll dip down to its minimum value, and then eventually it'll cycle back up to that maximum value again, and so on. So we're going to do a few things with this model. First, I'm going to graph it, and in order to graph it, I need to find different features like the amplitude and the period. Remember, amplitude is just that number in front. A is 850. The period is not 4/3. The period is 2 pi divided by 4/3. Now, in order to simplify this, we're going to keep change flip. I keep 2 pi, change division to multiplication, flip the fraction into 3/4, multiply straight across, and simplify. So the period is 3 pi over 2. So that means this population goes through a cycle in 3 pi over 2 years. I don't know about any of you. I'm not sure how to measure time in pi. That's not really how we do it. So if you convert this into a decimal, you will see that it's about 4.7 years. Now I'm going to use this information to graph. Before I actually graph the full function here with the plus 7,000, I'm going to show you what it looks like if that plus 7,000 wasn't even there. So we have our amplitude of 850. Cosine always starts at maximum displacement. So I'm going to have a point at 850, and it's going to take me 3 pi over 2 to go through one cycle of the period, or of the graph, cosine. The period is 3 pi over 2. So with cosine, we start up here at 850. Halfway through the period, we should get down to negative 850. And then by the time we get through one period, we should get back up to 850. So one period roughly looks like that. Now remember, these do go on forever, but between those 2 points on the top, that would be one period. So between 0 and 4.7 years, the population starts at its peak of 850, and then it dips down until it gets back up to 850 again after approximately 4.7 years, or 3 pi over 2. Now remember, this is about population. So this graph in front of me wouldn't really make any sense because I have a positive population and a negative population. But this wasn't the actual function. The actual function had this plus 7,000, which is a vertical shift up. So I'm going to take that function that I just drew, and instead, we're going to shift the entire thing up 7,000. Now, in this function without the shift up, you'll notice the x-axis cuts this graph in half. It cuts the top half from the bottom half. Instead of the actual function centered around the x-axis, it's going to be centered at 7,000. So the x-axis used to be the center. Shifting that up brings us to 7,000. I'm going to do the same thing with 850 and negative 850. Adding 7,000 to both of those numbers would bring me up to 7,850, and the graph will go down to 6,150. So remember, our period was 3 pi over 2. So that means the graph is going to start at its peak of 7,850. Halfway through the period, it'll dip to its lowest point, or its lowest population of 6,150, and then it'll cycle back up to 7,850 by the time we get through one period. And these do go on forever. It got pretty bad after this point, but it's a very rough sketch. Very rough sketch. So a couple things about this situation. One question we could answer is, what is the maximum population? Well, according to this function, it cycles through the same numbers over and over again, with the maximum population being 7,850. If we wanted to know the time it takes between maximum populations, that's just the period. Because remember, we're starting at our maximum population right here. The time it takes to get back to that maximum population would be the period of 3 pi over 2. But remember, we don't usually talk like that. We don't say it took 3 pi over 2 years. So if you convert that to a decimal, it's about 4.7 years.